Hey guys, welcome back. Today is day 57 and it's the second day of simplifying radicals. Today we're going to learn some new properties of radicals. So we start out with the warm up, and the first 5 perfect squares you should have had would be 1, 4, 9, 16, 25, and 36. Okay, the first 5 perfect cubes would be 1, 8, 27, 64, and 125. Okay, so perfect cubes would be, if you took the cube root, you'd get a whole number. And the first 5 prime numbers would start with 2, because 1 is not prime because it needs 2 factors. So 2, 3, 5, 7, and 11 would be the first 5 prime numbers. Okay, so a little review of what we did last class. We learned how to simplify a radical, and we can either identify the largest perfect square factor, or we actually did it making a factorization tree. We got the number into a product of prime numbers, and we can start out by multiplying 2 times, in this case, 84. And then maybe 84 is even, so 2 times 42. And then 42, you could say 6 times 7. And 6, you could say 3 times 2. So there's all our prime numbers. And because our index is 2, remember, if there's nothing there, the index is 2. We're looking for doubles. So I've got double 2's. So I'm going to pull out a 2. And that would be it. So everything else stays inside as the radicand. 3 times 2 times 7. Okay, so when we multiply those out, we end up with 2 radical 42. There's our solution for the first one. Okay, the next example that we had was negative 10 times radical 49x to the 6th. Well, negative 10, I don't want to forget about that, so I'm going to multiply that by. Okay, well, in this case, 49 is a perfect square, so it's really just times 7. And x to the 6th, if you think about it, if we had 6 x's, 1, 2, 3, 4, 5, 6, and we want groups of 2, you could think of 6 divided by 2 would be 3, so our x would be to the 3rd power. So what would happen there is nothing is left inside as the radicand, so this would just be negative 70 x to the 3rd. Okay, so moving on, we've got number 6. So outside we've got a 3x, and we're going to bring that down. And we're looking for the cube root. Well, the cube root of 27 is actually 3, or you could have done it like this and said 3 times 9. Okay, and you can see we just have triple 3's. Our index is 3, so we're looking for triples. Okay, with the variable, if we had 3 x's, there would just be a group of 1, so x to the 1st power. And if we had 9 w's, 3, 4, 5, 6, 7, 8, 9, you can see 9 divided by 3 is 3. So our w would be to the 3rd power. We'd multiply this out and we'd get 9x squared w to the 3rd. And there would be nothing inside as the radicand, so we just leave it like that. Okay, so that leads us to today's lesson. So we're just going to start out by doing a review. A radical expression in simplest form if the following conditions are true. There's no perfect square factors other than 1 in the radicand. No fractions are in the radicand, and no radicals appear in the denominator of a fraction. So if I look at the first one, I'm going to take the number 50 and I'm going to split it up. I'll do 2 times 25, and 25 I can do 5 times 5. All right, so I'm looking for my index is 2, so I'm looking for my doubles. I have double 5, so that's going to come out. And then what's left inside is just 1, 2. Okay, so it's not crossed out. Now with my variables, if I have 4 m's and I want to put it in groups of 2, that means that I have 2 groups of 2, so my m would be to the 2nd power. And then I don't have anything left over, so nothing would go in as the radicand. Now with n to the 3rd, I actually have 1 group of 2 n's with 1 left over. So that would be my solution there. Okay, looking at number 2, notice I have an index of 3. So I'm actually going to draw this out right here. Okay, so I don't forget that little 3. I'm going to take the coefficient and break it apart. I've got, let's do 64 times 2. And 64, I could do 8 times 8. And 8, I could do 4 times 2. And 4 times 2 again. And my 4 would be 2 times 2. Okay, be careful that you circle, okay, all of your primes. All right, now since we're looking for triples, we're going to get triple 2s, 1, 2, 3. So I'm going to put that here. Actually, I'm going to erase this and give myself a little more space so you can see it. Okay, it's cube root, so we pulled out triple 2s. And if I look at this, I have another triple 2. Okay, and then what's left over is, in this case, that's a 2 times 2. There should be a 2 in there. Okay, 4 is 2 times 2. All right, so then with our variables, x to the 7th, if we had 7 x's, 4, 5, 6, 7, and we're looking for triples. Okay, so that would be 2. Actually, let's see, we got our triples. We've got 3 x's. Okay, with 2 groups, so it would be x squared with 1 left over. And then our y to the 6th, if we do the same thing, we got 6 y's, groups of 3. We've got 2 groups of 3, so y would be squared. All right, so when we multiply this out, it would be 4 x squared, y squared, and then it would be cube root of 2x. All right. So that would be a review of simplifying radicals. So number 2, just be careful. The index here is 3, so we're looking for triples. I hope I didn't confuse you in there. We're looking for 3 of a kind. So we had two sets of 2 were 3 of a kind, and I had a little mistake there when I said 2 times 3 was 4. Okay, so just catching that. So, and let me just erase this so you can see it a little bit better, but that is a 2x inside. Okay. All right, so today we're going to add on a little bit, and we're going to learn how to multiply radicals. So to multiply them, you just multiply the numbers under the radical together, unless they're perfect squares. If they're perfect squares, you can actually find the square root of it, or the perfect cube, find the cube root, and then multiply. But you'll get the same number no matter which way you do it. So 3 and 18, they're both not perfect squares, so we're just going to multiply them together, and we get 54. From here, we want to put it in simplest radical form. So let's say 9 times 6. We're going to do it the same way we did last class. So 9 is 3 times 3, and 6 is 3 times 2. Okay, so since our index is 2, we're looking for doubles. We have a double 3, so that gets pulled out. And then 3 times 2 is left inside, so our solution is 3 radical 6. Okay, number 4. All right, we're going to multiply them together. Neither one's a perfect square, so we get radical 150. Okay, now I'm going to say maybe 5 times 30. That's what we started with. 5 is prime. And then we can say 30 is 6 times 5. And then 3 times 2. Okay, since our index is 2, we're looking for doubles. And when we look at this, we have double 5s. That gets pulled out. And then we have 2 and 3 left inside. So 5 radical 6 would be our solution. All right, the next one, a couple of different ways you could do this. You could either multiply them both together and get 100. And the square root of 100 is 10. So there's your solution. Or you could have said the square root of 4 is 2. The square root of 25 is 5. 2 times 5 is 10. Either way, you get the same answer. All right, number 6. Okay, notice we have a number -3 on the outside, so we've got -3 radical 2 times radical 4. Well, radical 4 is a perfect square, so we could just say times 2. So -3 times 2 is -6, and then we get our radical 2. You could have done it that way. If you didn't recognize that 4 was a perfect square, you could have multiplied these two together and had -3 times radical 8. And then from here, you could have simplified the radical 8 into 2 times 2 times 2. This would have been -3, and we have our index is 2, so we've got a pair of 2's. And left over, we have a 2. So we get the same answer, -6 radical 2, if we did it that way. Okay, So this might be a good opportunity for you to pause the video and try them yourself, okay? If not, I'm just going to keep going here. So this would be square root of 25, and that would be 5, okay? Number 8, when multiply and get radical 90. So this one we're going to put it in simplest radical form. I'm going to say 9 and 10. 9 would be 3 and 3. 10 would be 2 and 5. So my index is 2. I'm looking for my doubles. So pull out a 3, and left over is 2 times 5, or 3 radical 10. Okay, number 9, they're both perfect squares. So the square root of 4 is 2. The square root of 16 is 4. 2 times 4 is 8. Okay, or you could have done it the other way and multiplied it. And if you did that, you would just get the square root of 64, which is also 8. So either way, your answer is 8. Okay, if we have the square root of 9 and we square it, it's really an inverse operation. So that's going to be the square root of 81, which is just 9. Okay, or you could have thought of that as the square root of 9 is 3, and 3 squared is 9. Either way. Okay. All right, now we're going to add or subtract radicals. So as long as what's under the radical then is the same, it's like combining like terms. So you're going to combine the coefficients on like radicals, but they have to be alike. So here our like radical is radical 2. We just take the coefficient, which is 2, and 6. We add it together. We get 8 radical 2. And that's our solution there. Okay. So number 12, if there's no number or no coefficient, think of it as a 1. Well, 1 minus 6 is negative 5, and the radical stays the same. So again, it's like combining like terms. Here we have a radical 6, so 2 minus 5 is negative 3, and then you've got your radical 6. Okay. So if we look at the next 3, they're not like radicals, okay? But we want to put them both in simplest radical form first, okay? So I've got radical 12, which could be, let's see, 4 and 3 and 2 and 2. So radical 12 could be represented as a pair of 2, so it's 2 radical 3. And then let's look at 27. 27, we could do 3 and 3, okay? So we crossed out those 2 2's. And 27 is 3 times 9. Whoops, got ahead of myself there. 3 times 9, 3 is prime, and then 9 is 3 times 3. So we can represent 27 as we're subtracting, so it's 3 radical 3. All right, once you have it in this form, 2 minus 3 is negative 1, or just negative radical 3. Okay. All right, so again, you might want to pause the video and try some on your own. 15, 3 radical 3 is already in simplest radical form. 27, let's do 3 times 9, and 3 times 3. So we've got 3 radical 3 plus a pair of 3's, radical 3. Okay, add the coefficients and we get 6 radical 3 is our answer. All right, so if I look at 16, let's see, we could do 2 radical 6. We could do 3 and 2, but there's nothing to match them up with, so this would just be 2 radical 6. And then with 54, we could do, let's see if that's in simplest radical form. We've got 9 and 6, 3 and 3, 3 and 2. Okay, looking for our pairs, so we're going to take that 2 radical 6, and we're going to add it to, let's see, we've got 3 times a pair of 3's. Oops, let's circle them. And what's left over is 3 times 2, which is 6. So we're taking 2 radical 6 and we're adding 9 radical 6, and we'll get 11 radical 6. Okay, so now we're going backwards. All right, so it's saying what value can be placed under the radical symbol to make the statement true. So think about putting that 5 back inside as the radicand. Now to take it out, we found the perfect square. To put it back in, we want to square it. So we're going to take 5 and we're going to square it and then multiply it by what's inside, okay? And so that would be 25 times 5, which would be 125. Okay, so you're putting that 5 back in by squaring whatever's on the out. You take whatever's on the outside and you raise it to the power of whatever the index is. And in this case, the index is 2. All right, here our index is 3. So we're taking what's on the outside, which is 3x, and we're cubing it, and then we're multiplying it by 5x. Okay, so we're going to cube that. So 3 is going to be cubed, x is going to be cubed, and that's multiplied by 5x. So we end up with 27 x cubed times 5x. So our final answer would be 27 times 5 is 135, and our x would be to the 4th power, because our rule is when you have the same base and you're multiplying, you add the exponents. Okay, again, going back in, we take what's on the outside. Here our index is 2, so I'm going to take 4x y squared, and I'm going to square it, and I'm going to multiply it by what's on the inside, 2y. Okay, 4x squared squared, so we're taking 4 squared, x squared, y to the 4th. I'm just using my properties of exponents, power to a power, times 2y. So 16x squared, y squared times 2y. 16 times 2 is 32. Our x is squared, and our y would be to the 3rd power. Whoops, I think I made a mistake in here. Nope, that's what I did right here. Our y is to the 4th power. I brought that down wrong. So 4 plus 1 is to the 5th power. So final answer would be 32 x squared y to the 5th power. And there you go. All right, highly recommend getting that homework done. Bye.